Question number 1. Which of the following diagrams addition of two vectors 8 and 6 Newton? We know that when adding two vectors, we have to consider first vector is 8 Newton and second vector is 6 Newton. If we can represent these two vectors by two arms of triangle, the resultant vector should be the line joining initial point and end point. 6 and 8 should be in same direction and resultant should be the line joining starting point and end point. Therefore, we can consider third answer is the correct answer for question number 1. Then question number 2, which of the following sets of forces never produces a zero resultant? There are three forces. If the resultant is 0, we can represent given vectors by using a triangle. Therefore, we have to consider the set of forces we can't represent by using a triangle. We know that 5, 5, 5 Newton in first answer, 5, 5, 5. There are same values. We can represent it by using equilateral triangle. Using an equilateral triangle. Then second one, small forces 5 and 5. The large force is 10 Newton. We know that 5 plus 5 equals 10. Therefore, we can represent it by using a triangle. But when drawing the triangle, we can get a straight line like this. If the largest side is 10 Newton, we can represent 5 and 5 on the same line. Therefore, resultant could be 0. Then third one, the largest, we can consider the largest force is 10 Newton. 5 plus 5 plus 10. Sum of remaining forces are equal to large force. Therefore, we can get resultant 0 for the third answer. Then fourth one, largest force is 20 Newton and we can get 10 plus 10 equals 20. Therefore, by using this method, we can represent it by using a system of forces, 0 resultant. Then fifth one, largest force is 20. It is less than the sum of other forces. Therefore, we can't represent fifth one by using a triangle. We can't draw a triangle because of the largest force. Largest length we have to represent is greater than sum of other forces. Therefore, we can't draw a triangle using this length. Then fifth answer will not produce a zero resultant. Then answer is 5. Question number 3. A kind of weight W hangs at rest from the end of a light inextensible rope as shown in the figure. If the weight of the spin balance S is negligible, the reading on its scale is. I will draw the diagram. It is like this. There is a pulley and the spin balance is at this place. Like this. Then we can mark forces. Weight of the child W, it is given as W, and there are two forces, tension. This spin balance is light spin balance. It means there is no weight for spin balance. Therefore, this tension is acting as the same value for the same rope. Therefore, we can consider equilibrium of child. This tension is the reading of spin balance. Then we can get there are two upward forces on child, 2T equals to downward force weight. Then we can subject T, W divided by 2. Then answer is 3 for the question number 3. Then question number 4. The diagram shows a uniform rod resting horizontally on two supports X and Y. The lengths PQ, QR, RS and ST are equal. As Y moves from S to T, keeping XY stationary, X is stationary. The reaction on the rod due to X, there is a rod like this. Support X is at this place and Y is at this place. We have to move Y to the right hand direction. When moving Y to the right hand direction, we can consider forces. I will consider weight of the rod, reaction at X and reaction at Y. There are different values. Therefore, I will consider this reaction at R dash. Then we can get the relationship by using torque around a point on the rod. I will consider the end point P and I will get torque around P. We can write torque around P mg into, if this rod is a uniform one, mg is acting at the midpoint. It means if the length of the rod is L, we can multiply by L over 2. Perpendicular distance should be L over 2. Should be equals to opposite torque. Opposite torque is given by R dash. R dash into distance from P. Distance from P is L over 2 plus this length. I will consider it as X. L over 2 plus X. Now we can consider when Y is moving to right hand direction, this X value is increasing. X value is increasing, it means this value L over 2 plus X value also is increasing. Now, if the perpendicular distance is increasing, the reaction should be decreased because of mg into L over 2. The torque in left hand side is constant. Therefore, we can consider that R dash should be decreased. R dash decreases. Now we can consider vertical equilibrium of the system. When considering vertical equilibrium, there are two forces in upward direction, R and R dash, should be equal to mg. Mg is constant for the rod. Then we can get when R dash decreases, R should be increases. When R dash decreases, R should be increased. We can consider given statement the reaction on the rod due to X increases. Reaction due to rod X is reaction due to X is R. It is increases. It is increasing. R is increasing and Y decreases. Therefore, we can consider increases and due to Y decreases. Second answer is correct answer for the question number 4. Then question number 5. Two spring scales of negligible mass are connected together and a 10 kg mass is hung as shown in the figure. Which of the following statements is true? We have to consider reading of given two scales. I will consider the system. There are two scales like this. And the mass is 10 kg. Two spring scales of negligible mass. Therefore, mass of this spring is 0 kg and this spring also 0. Then we can get tension. If the system is at rest, because of this 100 Newton, it is 10 kg in weight, in mass, 100 Newton weight. Therefore, we can consider tension of this part is 100 Newton. It is the reading of this scale. We can get it as 10 kg. And spring balances are massless, light spring balances. Therefore, this tension is not changing with height. And reading for this scale also 10 kg. Therefore, each scale will read 10 kg. Second answer is correct answer for the question number 5. If there is a weight for a spin balance, for the spin balancer, we have to consider that when moving in upward direction, tension of the cord should be increased. Tension of the cord increases. Therefore, we have to consider there are different values. But in this system, spin balancers are light, weightless. Therefore, we can consider there is the same reading, same tension for both spin balancers. Then question number 6. The system of coplanar forces acts on a rigid body. If the resultant of moments of the forces about a certain point on the body is 0. Consider the following statement. A. The resultant of the moment of forces about any other point on the body is always 0. No, it is incorrect. We can't get that. If the resultant torque is 0 around the point, the torque around all points should not be 0. Therefore, we can't get it as a correct statement. B. The body must be in equilibrium. No. Because of to the equilibrium, torque around any point should be 0 and the resultant force also should be 0. Therefore, statement B also incorrect. Then part C, the resultant force acting on the body must be 0. No, we can't get it as a correct statement because of we can't get the resultant force is 0 due to resultant torque is 0. Then all A, B, C false. Answer 1 is correct for the question number 6. I will consider again. First one, they have given a system of coplanar forces acting on a rigid body. If the resultant of moment of forces about a certain point on the body is 0. Consider the following statements. A statement, the resultant of the moment of force about any other point on the body is always 0. We can't get it because of there is no theory. If the resultant torque around the point is 0, torque around any other point should not 0. Then second one, the body must be in equilibrium. We can't get it as an equilibrium because of we have to consider the resultant force and torque around all points. Then C, resultant force acting on the body must be 0. We can't get it by considering torque. Therefore, ABC, all ABC are false. Then answer 1 is correct for the question number 6. They have given that answer is 5, it is false. A man of weight 500 Newton standing on a platform P supported by 2 light strings passing over 2 light smooth pulleys A and B, supports himself by pulling the string as shown in the figure. If the weight of the platform is 1000 Newton, the force exerted by the man on the string to keep the platform. I will draw the diagram. It is like this. There are 2 pulleys. This is the platform. Tension 1. It is acting up to this stage. Then tension 1 is the given force by man. Given force by man to the rope. And when considering equilibrium of this pulley, there are 2 forces in downward direction. Upward force should be sum of the 2 forces. We know that tension of cord is same. Therefore, tension for this point also T1. T1 plus T1, 2T1. Then from this cord, there is a 2T1 tension on the given platform. Now, mass of the weight of the man is 500 Newton and weight of the platform is 1000. Therefore, we can mark 1500 total weight. We have to consider the reaction due to mass. There is another force. Weight of the platform is 1000. Full weight of the man is not acting on the platform because of there is a force T1 on man. Then we have to consider the reaction of man. I will consider forces on man. Tension is in upward direction, T1, and weight is in downward direction, 500 Newton, and there is a reaction due to platform. We have to get a relationship for the reaction first. We can consider the equilibrium of man. R plus T1 equals 500. I will subject R 500 minus T1. Now we can get there is another force on platform. It is reaction. Full weight is not acting on the platform. Therefore, we can write a relationship for the equilibrium of platform. There are two forces in upward direction, 2T1 and T1, 3T1 in upward direction should be equals to 1000 plus R in downward direction. Now we can get 3T1 equals 1000 plus we have found R is 500 minus T1. Now we can get T1 to the left hand side. 4T1 equals 1500. T1 equals 1500 divided by 4. 15 divided by 4, 3. 12, 3 remaining. 30 divided by 4, 7. 2 remaining. 20 divided by 4, 5. 375 Newton. Then correct answer is 5 for the question number 7. Question number 8. Which of the following group of forces acting on a body cannot have a zero resultant force? We know that if the resultant force is zero, forces could be represented by using a triangle. We can draw an equilateral triangle for the first group. There are same forces. For the second group, the large force is 4. It is less than sum of other forces, therefore we can represent by using a triangle. Third one, we can consider a large force, 2 Newton. It is less than 1 plus 2 remaining forces, therefore we can draw a triangle. In fourth one, 1 plus 1 equals 2, therefore we can draw a triangle. For the fifth one, the largest force, 4, it is less than the sum of other forces. So it is greater than the sum of other forces. Therefore we can represent it by using a triangle. Then answer 5 is correct answer for the question number 8. It also incorrect in the answers in the book. To represent, then you have to remember. Now we have found two questions. You have to remember to represent to the resultant equals to 0. We have to consider the fourth triangle. When considering triangle, if we can't represent given forces by using a triangle, then the resultant is not 0. To represent the given values by using a triangle, the large side should be less than or equal to the sum of other two sides, which is the requirement. Then question number 9. The diagram shows two boys pulling a bucket of water from a well. When the following graph correctly represents the variation of tension T in the string width angle. There are 3 forces on this point. In upward direction, this tension and this tension. In downward direction, weight of the bucket. I will consider it as LT. And they have marked, there are same angles theta. Now we have to consider equilibrium of this X point. we can consider the vertical equilibrium. Then we can write for the vertical equilibrium of point X. Upward forces T cos theta plus T cos theta, 2T cos theta equals downward force mg. For the initial situation, we can consider that theta equals 0. If theta value is 0, we know that cos theta is 1. Therefore, we can get it as 2T equals mg. Cos theta value is 1. When T equals mg divided by 2. When theta maximum, it means theta value 90. Cos 90, 0. Cos theta 0. Then 2T into cos theta 0 equals mg. We can subject T, mg divided by 2 into 0, 0. mg divided by 0 means it is infinity, it is the larger value. Then it should be increased because from mg over 2 to infinity. mg over 2 to infinity. Then we can get the shape of the graph 1 over 5 like this, mg over 2 to infinity. We know that a cos curve could not be a linear graph, and there are three graphs, tension increasing with time with theta value. We can't identify the correct answer from first one or the fifth one. Then we have to consider 1 over 5 for the as the answer for question number 9. Question number 10. The force F shown in the figure can be obtained by adding the forces F1 and F2 in. There are three diagrams A, B and C. We can consider A. In figure A, there are two forces like this, F1 and F2. We know that if we represent these two forces by adjacent sides of a parallelogram, the resultant should be the diagonal. It is in the direction of F, therefore it will correct. Then from answer B, there are two forces like this. Those are acting in the same direction. Therefore, resultant should be the line joining the starting point and end point. It also like this. Therefore, it also correct. In part C, there are two forces like this. We have to consider the resultant. When considering resultant, we can get these forces acting in this direction. Therefore, I will bring it to this place, and we can consider the triangle. Now, all three resultant forces are in the same direction. And it is equal to the F force in the direction of F force in the figure. Therefore, we can consider all A, B and C are correct. Answer 5 is correct for the question number 10.